Good day, students. Today we have a very important question in physics. The question is, a polar charge Q1 is located on the positive x-axis at y is equals to the positive y-axis at y is equals to 0.3 meters, and an identical charge Q2 is at the origin. So it's at y is equals to 0.3, then the other one is at the origin, but they are identical. I mean, they are the same. Find the magnitude and direction of the total force these two charges exert on a third charge Q3 4 nanocoulomb, that is at the positive x axis at x equals to 0.4 meters. Now take Q1 equal to Q2 to be 2 nanocoulomb. Q1 is 2 nanocoulomb, Q2 is 2 nanocoulomb. So let's also bring out our charges. Q1 equal to Q2, which is this. This is equivalent value in coulomb. For Q3 is this equivalent value in coulomb. And I told you, if we are looking at coordinate system, let's x-axis, y-axis, ijk, we must sketch. So for you to understand this sketching, that is one of the solutions to the question. So if you cannot sketch this, it means you will not be able to solve the question. That is the major thing. So it's very simple to sketch it out. All you have to do is to get the understanding. I told you, if you have a coordinate system, draw the coordinate out. Just draw your horizontal line for x, vertical line for y. So this point in which both the horizontal and vertical intersected is going to be the origin. So this is the origin now. This is the origin. It said Q1 is at the positive y-axis at y is equal to 0.3. So you just measure 0.3 to the upper side. The upper side of y is positive, the downside is negative. Left side of y is negative, right side is positive. Just understand those simple terms. It's very important. So you just measure 3 to this side, then you put your Q1 there. So from here to here now is 3, 0.3, not 3, 0.3 meters. Then Q2 is located at the origin. Just put Q2 at the origin. See it? It's very simple thing. Then Q3 is at 0.4 meter from to the right. That's so the positive x-axis. Just measure 0.4. Put Q3 there. That's all. So we're going to have this, and this. So next thing, what is the line of action between? Because we're looking at the force on Q3. So we're going to look at force on Q3 and Q1, Q3 and Q2. What is the line of action of this force? Look at the line of action here. That's why I just drawing these rookie lines here. And what is the distance between this and this? What is this distance? We know that from here to here is 3, from here to here is 4. What will be this? So if you check this diagram now, this shape, well, this shape is a right angle triangle. And here is the hypotenuse because it's facing this angle 90 here. So since here is the hypotenuse, the square of this hypotenuse must be equal to the square of this plus the square of this. Or this hypotenuse will be equal to the square root of this one square plus this other side square, which is r1 is equal to 0.3 square plus 0. From Pythagoras theory, give us 0.5 meters. And as well, also from this same rule, from SOHCAHTOA, tan of this angle here, this angle between this angle is vertically opposite to this, so they are equal. Vertically opposite angle are equal. So this and this are equal. So this angle now will be, the tan of this angle now will be opposite over adjacent. The side facing the angle is opposite. This side is already hypotenuse. This other one will become adjacent. So the tan of this angle will be opposite over adjacent. That's why I'm having this 0.3 over 0.4. So this theta now will be tan inverse of this other side. Then we'll check what we are going to have from the. Then next, how would this Q1 react to this Q3? Now this Q1 is going to be repelling this Q3 to this side since they are both positive. So this one will be repelling this one to this side. That's why we call it F1. That's force coming from Q1. This one is also positive. It's going to also be repelling this Q3. This is positive to this side. So this one is force of repulsion to this side, force of repulsion to this side. So the two forces we are going to have now will be, one is pushing it to this side, the other one is pushing it to this side. So there are two forces we are having now. So if you can get this force, you can get this force. As we are looking for only the magnitude, we'll just use Pythagorean law of vectors or forces to find the net force, which is will be the net force will be the square root of this square plus this square plus 2 times this and this cos of this angle will give us the magnitude. But the direction is actually important in this question. So that's why if I want to find the net force of this one, I'll use resolution of forces. I'll just resolve it to the positive s, I resolve it to the x and y, then find the magnitude and also as well the direction. So look at how to find the magnitude of these two forces now, and how to get the total resultant force. So I already said theta equals tan inverse of this, which is 37 degree. F1 will be KQ1 Q3, force between Q1 and Q3, force equal to Q2 and Q3. So apply this formula, substituting the values, you're going to have this. Do the same for F2, you're going to have this. The next, I'm going to resolve these forces now by utilization of forces. Remember, we're having these two forces, this and this. That was F2, so that was F1. So I just brought out only the force because that is what I want to resolve. So you draw horizontal line and vertical line. A vertical line, have horizontal line. So here is the first quadrant, second, third, and fourth. Or this side is the downside, upper side, left hand side, right hand side. So if you want to resolve to the x side, what you just do, any force go to the s direction that's truly horizontal. There's no need to resolve that one, just add it. Then any force truly vertical will not join for x side. Then this force truly horizontal and will not join for y side. So this one is truly horizontal, so we just have 4.5 times 10 power 7. That's why it's just there. Plus this one now is making an angle of 37 degrees with the horizontal, and it's to the right hand side as well. So just see right, which is positive. This, then we now use to multiply the cosine of this angle. Let's have to resolve it to the horizontal side. Hope you get it. Then because of this, then you're going to have this. Then for the y side now, this force that is moving along the horizontal line will not join the y side. It will be 0 in the y side. But if we take it, the angle between this horizontal and this horizontal is 0. If this one now sine 0, we still give it 0. Because this one that is truly horizontal, if you want to do for y, for the y component, you don't add this one that is truly horizontal. Just leave it alone. Then let's work with this only. Now why is this one negative? It's negative because you go to the downside of y. The downside of y is negative. Hope you can still remember that. Yeah. So we have minus this. Then instead of you to use cos now, for y, you will use sine of the same angle. So minus this sine of that same angle. So we have this component for y. So the force you have now is this. The component of these two forces now is this one to the x side and this one to the y side. That's why I'm writing it this way. So the total force is this one to the I side. I means x side. Then we have this one which is minus this to the j side. J means y side. Now the magnitude of this force, or the magnitude of this one, is the square root of x side plus y side. Whether this one is negative or positive, that's not our business. The magnitude must be the square root of x side square plus y side square. Remove the negative sign because if you square it, the negative sign will go. That's why I'm having this. The square root of x side square plus y side square. Then we'll have this as the magnitude of the force. This is the magnitude. Now let's check for the direction to the positive x-axis. Let's check for the direction to the positive x-axis. The direction now will either be anti-clockwise to the positive x-axis or clockwise to the positive x-axis. So for anti-clockwise now, if y is negative and x is positive, to get the direction in anti-clockwise way, just take 360 minus the tan inverse of sigma f of x, that is y component, divided by x component. F of y, sigma f of y divided by sigma f of x. You have 360 minus tan inverse of r. I did something like this when I was doing complex number before. If your imaginary is negative but the real side is positive, you take 360 minus tan inverse of b over a. I did something like this before. So if you follow up this class, this will not be a problem to get. So this is the direction to the positive x-axis, which is the tan inverse, 360 minus tan inverse of y component minus x component. So you're going to have 346 degrees in anti-clockwise direction to the positive x-axis. Or you can just say the tan inverse of this s and y component divided by x component, which will give us minus 14 degrees. This one being in clockwise direction. So for clockwise direction, angle will be negative, anti-clockwise will be positive for angles. Take note of that. Take note of that. So we can also present this force in magnitude direction in this one is in rectangular form. This one is the form of magnitude, direction. Let's also present this magnitude and direction in polar form for you so that you see it. And that way you can also see this magnitude and direction of the force. Look at it here. See, this is what I'm saying. This is what I'm saying. So the total force will be this to the angle of this, or this to the angle of this. If you express this one now using vector, you're going to have that components back. So this is how to find the magnitude and direction of this force you are actually looking at. Thank you. God bless you. See you guys next time.